Okay, I understand some of you are finding the Hess's law calculation difficult, so this is the first question I asked you to do in the workbook, page 66, Chemistry Live workbook. Question 14, it looks like this. So the question says, calculate the heat of reaction of the following reaction, and they've given you one equation like this, and delta H equals we don't know. So what they're trying to get you to find out is this equation. So we call that the goal, okay? So the goal is to see. Now, I'm not expecting you at this stage in chemistry to understand what all these chemicals are. We just need to know how to manipulate them. But I would expect you to know this one. So CH4, if you weren't sure what it is, C, 1 carbon, H4, 4 hydrogens, looks like this. So it's methane. So methane. Okay, methane and 4 chlorines gives you CCl4 and 4 HCls. That's the reaction. Now, Hess's law states that if a reaction happens in one, what would you say? If it happens all in one, or if it happens in many different stages, so if it happens in one stage or if it happens in many stages, the overall heat change should be the same. So this reaction here is happening in one stage. This same reaction is happening down here, but it's happening in 1, 2, 3 different stages. So you start off with methane, you start off with chlorines, you end up with CCl4 and 4HCl. So you're starting off with the same things and you're ending up with the same things. The heat changes here, though, we can see are given to you in 3 different numbers. We want that to be one heat change. So what we're trying to do is, looking at my goal, I have to see, do I have a methane here anywhere in my mechanisms? So I have one methane here in the goal, okay? Do I have a methane anywhere down here on the reactant side? The reactant side is everything over here on the left-hand side, okay? We call them reactants. Everything that's over here then on the right-hand side, right, we call products. So, likewise, I've got my 3 arrows here, 1, 2, and 3. Everything to the left of them is reactant. Everything to the right of them is a product. So I'm looking for methane, CH4, anywhere down here as a reactant. I don't have it. I do have it, however, over here, but it's as a product, so that's no good to me, which means I need that methane on the left-hand side of my balanced equation. So I put in a little arrow like this to indicate that I'm going to swap all the reactants with the products and all the products with the reactants. So when I flip everything from the right-hand side over to the left, I have to flip everything from the right-hand side, the left-hand side over to the right. Likewise, my heat of reaction is going to change sign from a negative to a positive. So that's the alteration that I'm going to make to equation number 1. Second thing I need here is chlorine on the left-hand side. Do I have chlorine as a reactant anywhere on the left? Yes, I do. I have it on both this line and on this line. Because I have it on 2 different lines, I'm actually going to leave it just for 1 second until I sort out these 2 products before I go and find out which line I'm going to find my chlorines in. So as a product, I have CCl4. I only need one of them, and I have one of them here, and it's on the right-hand side of this equation, which indicates it's a product. So perfect. I don't have to do anything to that second line. The last thing I'm looking for is HCl, and I have it here. However, in my balanced goal equation, I have 4 of them, whereas down here I only have 1. How do I make 4 of them? I have to multiply that whole line by 4. So I'll end up having 4 HCls, but I also have 4 times each reactant product, and I'll have to multiply Hess's law heat of reaction by 4. So whatever you decide to do to a particular equation, you have to do it the whole way across. Now, at this stage in my copy, I'm going to draw a second line like this. And what I do here is I rewrite out the 3 equations, 1, 2, and 3, except this time I do whatever alterations I've decided I'm going to do to them. So sorry, you will notice at this stage as well, I haven't actually figured out yet where I'm going to get my chlorines from, but because I have options, I'm going to just leave it to the end and hope that they'll appear in my equations. So to the first equation, equation number 1, which is here, I'm going to swap everything on the left-hand side with what's on the right-hand side, everything on the right back to the left. So I end up with methane now, which was here on the left, a carbon, and 2 times H2. To my delta H, I'm now going to flip the sign. So instead of minus 74.9 kilojoules per mole, I have plus 74.9 kilojoules per mole. To equation number 2, I decided I'm not going to do anything, so I'm going to leave it exactly the way it is, which means I leave my heat of reaction exactly the way it is. Last thing, to equation number 4, I'm going to multiply everything by 4. So half of H2 by 4 has now become 2H2 plus half of Cl2 has now, 4 times Cl2. So 4 times half of Cl2 is 2Cl2, because 4 times a half is 2. 4 times HCl is going to leave me at 4HCl. And likewise, to my heat of reaction, I'm going to use a calculator to multiply it by 4. So it's 4 times minus 92.3 kilojoules per mole will give me minus 369.2 kilojoules per mole, like so. Now, at this stage, I take the red pen out again. I'm ignoring all of those original 3 equations because I'm now focusing on these 3. And I'm going to see, do I have what's on the left-hand side of my goal on the left-hand side in these equations? Do I have what's on the right-hand side of my goal in the right-hand side in these equations? First thing I need is methane, CH4, and I have it there. Second thing I need is 4 chlorines, and voila, I have 4 chlorines there. CCl4 on the right, I have on the right here, and 4Cl on the right, I have on the right here. Now, at this stage, I'm hoping that everything that's on the left-hand side will cancel with everything that's on the right-hand side. So I have 1 carbon on the left, it cancels with 1 carbon on the right. 2 hydrogens on the left cancels with 2 hydrogens on the right. So that means my reaction or my equation has worked out. So I'm going to rewrite out the goal equation again, which is CH4 plus 4Cl2 gives you CCl4 plus 4HCl. Now, what I was trying to figure out up here was the overall heat of reaction. Because the fact I've managed to rejig these equations in order to get the goal and everything else cancels, I know that by adding up these 3 heat of reactions, I'm going to find the overall heat of reaction. So the 3 numbers are 74.9 minus 139 minus 369.2, and you get an overall heat of reaction to be minus 433.3 kilojoules per mole, like that.